Hello, everyone. A very good morning. I am Geeta, and it's my pleasure to welcome you all on behalf of Solar Quarter, First View Group, and of course, our exclusive partner for today's event, Trina Solar. As we all know, today's convergence is very special as the Solar Module Super League member Trina has achieved one more milestone with their latest edition of ultra high power 670 watts version of the Vertex series. We are privileged that Trina Solar, which is leading the solar PV industry in the world, gave us this opportunity to organize this very special event. And here we are going to unveil the charismatic features of Trina Solar's Vertex 670 watts module and TrinaTracker solutions, and how this innovative and reliable connection can bring higher power and can bring down the LCOE. So without any delay, I would like to invite Mr. Lim Chang Boon, Trina Solar Asia Pacific, Head of Product and Marketing APAC, and Mr. Andrew Giholi, Head of Trina Pro APAC region, and request them to let us know something more about this amazing product. The screen is all yours. Mr. Lim?
Yes.
Could you start the presentation?
Okay. Thank you very much, everyone, for the time to join in the webinar today. And thanks again to Solar Quarter for organizing this, and also to all the key experts on the panelists for the time today. So I'm Lim from Trina Solar. I'd like to take the opportunity to introduce to you once again on our Vertex series and what are some of the new developments that we have since the last webinar. So just a very brief introduction again on Trina Solar as a company. So we are founded in 1997 and has been in the solar industry for over 20 years. So one of the very, very key milestones is that we have relisted again in Shanghai Stock Exchange last year. Now, of course, another result that we are very proud to say, we have been ranked top most bankable module supplier for 5 times in a row by Bloomberg. At the same time, just a recap on our presence in APAC. So over the last 3 years, we have shipped almost 8.9 gigawatt of module shipment among the top 3 supplier for module in the Asia Pacific region. And for India itself, we have a cumulative more than 5 gigawatt of shipment. So just to recap again on the module power trend, which has been very exciting over the last 10 years. So especially over the last 2 years in 2019 and 2020, we see the breakthrough in terms of the power bin from the 400 watt to the 500 watt. And then from this year, we are seeing the 600 watt and the 670 watt coming into the market. So this has been made possible by a various improvement in the technology and of course the widespread adoption of the PERC cell technology and also the larger wafer size. So once again, we look back again on the LCOE, levelized cost of energy, as the most key important factor in all the projects by the developers. So as a module component supplier, our contribution here will be in terms of in the total cost, how our modules, our power bin, our reliability, and of course the power generation is all the contributing factors to achieve the lower LCOE for the solar system. So this is the Trina product roadmap that has happened over the last few quarters. So since last year, 2020 Q3, we have started our 500 watt supply. And then in November, we have also launched our 550 watt and started supplying to the market. So for the higher power bins of 600 watt and 670 watt, this we are expecting to start very soon, from Q2 to second half of this year. So besides the larger footprint, we also have the smaller ones, which is for the residential market. So we have already started to supply our 400 watt module since February this year. So these are all based on the 210 mm cell size. So this is the comprehensive product model list that we have now, mainly covering the two different cell size, the 166 mm and the 210 mm. So as you can see here, for the 210 mm, we are covering quite a wide range of power bin from 400 watt all the way to 670 watt. So these are all targeted for the three different segments: the residential, the commercial industrial rooftop, and of course the ground-mounted utility projects. So what are some of the technologies that we are using in our solar module? So starting from the top left corner, you will see that we have adopted the largest wafer size that is available now in the market, the 210 mm. So to match with this 210 mm, we have also increased our number of bus bar. So you can see for 210 mm, if it's a 1/3 cut, it will be about 10 bus bar, and half cut will be 12 bus bar. So at the same time, as the wafer cell become bigger, we also upgrade our cutting technology. So you will see in the market now, half cut cell has almost become the norm for all the different suppliers. So as the wafer size become bigger, so we upgrade to a non-destructive cutting using a lower temperature laser. So this is to maintain as much as possible the mechanical loading capabilities as compared to a non-cut cell. Then at the same time, we have also used the high density interconnection technology. So basically, this will help to reduce the gap size between each cell so that we can reduce that few of the overall dimension of the module to have an optimized module efficiency. So I'll also start off with the smaller ones, the Vertex S 400 watt. So these are available in the three different variants, and they are incorporated the few key technologies that I've mentioned earlier. So this is mainly targeted for the residential rooftops. So you can see we have put a lot of thought into how to optimize the size, the dimension, so that it can fit nicely and maximize all the rooftop, residential rooftop space. So when we compare the same size rooftop to the previous generation of 158 or 166, you will see that the Vertex S is able to achieve a higher system capacity compared to the others, and this will translate to a higher power generation over the 25 years lifetime of the system. Then next will be our Vertex bifacial and monofacial. So this will be the power bin range of the 550, 600, and the 670 watt. So this is also based on the technology mentioned earlier, and we maintain our high reliability with the first year 2% derogation and a yearly derogation of 0.55% for backsheet and 0.45% for the glass. So using the Vertex 550 watt as an example, so you can see this is based on a 5x11 layout using a half cut cell, and it's based on a low voltage, high current design. So the key advantage of this low voltage, high current design, we can see it when we put it at the system level. So in this particular site, as a case study, a 1500 volt system with a lowest temperature of -10 degrees, we can actually install up to 36 modules per string as compared to the others. So this gives us about 35% more power per string. And this is a very important factor which will cascade down when we calculate the balance of system costs. So we have done extensive studies together with DNB and on the tracker scenario. So this is based on two particular sites that we have chosen, one in Spain and one in US, where we compare the higher power bins, the 545 with the 500, with the 450 and the 535. So this is on a one portrait tracker scenario. So based on the evaluation results, we do see that the EPC cost has decreased for the higher power bins. So this is mainly coming from the less number of modules used, so there's less installation work to do. And Trina low voltage design also uses less strings in the whole system, so there's less DC cable costs and also wiring work. Then from the tracker perspective, the total length of tracker use is also reduced. So there's cost savings at the tracker side also. So these are a bit more details on the assessment interpretation. So as mentioned, these are the three key saving points that we have found out from this analysis. So besides one portrait tracker, we have also compared together with the two portrait tracker, the two portrait fixed tilt, and the four landscape fixed tilt. So we can see that the results are pretty conclusive that by using a higher power bin, we are able to get cost savings at the BOS level. So next will be our Vertex 670 watt module. So this is announced just a couple of weeks back. So you can see here, this is based on a 6 columns design. So 132 cells of 210 mm cells, half cut. So you see that the size here is about 2.3 by 1.3 meters. Then for backsheet weight is 33.9 kilo and bifacial is 38.7 kilo. So this is also based on a low voltage design concept. So we have a lot of questions coming on the reliability of these larger footprint modules, especially now that the size has become bigger. So one of the key concerns will be on the loading capability. So to achieve the required IEC standards of 5,400 Pascal front and 2,400 Pascal back, we have did some optimization in terms of the frame itself. So this has already passed all the required testing, and we are going to deploy this into our 670 watt Vertex module. Then another common question that was always raised out is on the transportation and logistics, because we all know the current 40-foot container dimension. So how can these bigger modules fit into a 40-foot container? So you can see on the left side is a conventional packing with a horizontal two stack, where we stack two pallets on top of each other. And then on the right is our new so-called innovative packing for vertical placement. So this is what it will look like inside a 40-foot container, where there's about 18 pallets per container. So you can see, as compared to the lower power bins, we can actually pack up 12% more power, up to 12% more watt peak inside a single container. So of course, we also do the analysis at the actual system level in this case study of 100 megawatt. So as compared to the lower 540 watt module, we can see the savings coming from the racking, the foundations, the cables, and the installation time. So overall, there's an improvement in LCOE up to 1.2%. But at the same time, we have also worked with various inverters company because this is a high current module. So on the left is a central inverter, so there's no problem matching with the central inverter. So there's a need to upgrade the fuse capacity from 15 amperes to 30 amperes to cater for the high current. Then on the right is a string inverter. So we have worked with all the major inverter suppliers. So they have the compatible inverter model that can match with these high current modules that will be available or are already available in the market. So besides this, this is a large footprint module. So we think that it will be most widely adopted in terms of the ground mounted projects. So Tracker itself is a very key development that's happening now for the ground mounted projects. So we have also worked with the top 8 tracker suppliers to make sure that the design and the overall tracker length is compatible with our Trina Vertex modules. So overall, from Trina perspective, we are very optimistic and aggressive on the 210 mm technology. So we target to increase our capacity aggressively in 2021 to support the whole industry transition to the 210 mm wafer. So this is some case study example where we can adopt in the utility projects together with the tracker system. So in conclusion, this is our Trina Vertex family. So we have the range from 400 watt all the way to 670 watt, catered for all the different segments. Yeah. with that, that's all for my presentation. Thank you.
Thank you, Mr. Lim, for the wonderful presentation. Do you have a presentation from Mr. Andrew as well?
Yes, hello there. Hi, everyone.
Hello, Mr. Andrew.
I'll just share my screen briefly. Can you see my screen okay?
Yes, yes, it is.
Yes, we can.
Okay. Well, thanks very much, everyone. It's an absolute privilege to be here with you today, addressing this super exciting India market. My name's Andrew Gilhooly. I'm Trina's head of sales for our Trina Tracker in Asia Pacific. I actually work from Melbourne in Australia, but managing not just the Australia market, obviously the India market, which we're talking to today, also Malaysia, Vietnam, the interesting emerging markets in Central Asia like Kazakhstan and Uzbekistan and so forth, right the way over to Israel. So pretty big patch. I'd just like to start today by saying I'm hearing about what's happening in India with regard to COVID. So I hope everybody on the call and your families are all staying safe and keeping out of harm's way. We went through a bit of a tough time in the middle of last year in Melbourne and came through it and almost back to normal now. So keep the faith, and I'm sure things will get back to normal very, very soon. So without further ado, we'll move on to addressing how Trina's tracker technology is really a synergy of Trina's large format modules onto our proprietary tracker technology, and how that can basically unlock more value for our customers and ultimately achieve a lower LCOE, including in the India market. So first and foremost, Trina's vision or mission, if you like, is to become a world-leading PV and smart energy total solution provider. How are we going to do that? So you're probably familiar with Trina at its core being a vertically integrated Super League module manufacturer, well diversified amongst residential, commercial and utility scale. So we're really well positioned to navigate through the ups and downs of the industry as different segments come on and off stream in different markets. We're really well diversified in that regard. A few years ago, strategically, the management at Trina saw an opportunity where they basically saw the PV marketplace becoming more fragmented and more commoditized, and saw an opportunity to go downstream into providing complete solutions. So we have an in-house development team, also a C&I solutions business. And what I've highlighted here is the Trina Pro / Trina Tracker business, which really is the core of the solutions business. A couple of years ago, we acquired a Spanish tracker company called Enclave. We increased that investment last year to make them a wholly owned subsidiary, and went through a rebranding exercise. So it's now completely relaunched into the market as Trina Tracker. We're investing very heavily in the tracker technology. We've hired a ton of people on the R&D side, lots of people on the front end to sales, on the sales side of things. And then further on, downstream, we've actually launched now our energy storage solution and smart microgrids, and we have Energy Cloud proprietary SCADA-based solutions in the wings as well. But really, it's the same story globally, and I think this is the key focus of the webinar today. We're now regularly seeing the combination of single-axis tracking and bifacial technology regularly delivering significantly lower LCOE or cost of energy as compared to fixed tilt solutions. That's bearing out in pretty much every market globally, as you see in the top right. This slide is actually already out of date. We're seeing in the Middle East bid pricing getting much closer actually towards 1 cent per kilowatt hour now, truly staggering. And we see in the middle there, the end of last year, the bid pricing, super low bid pricing in India, getting as low as 2 rupees or even lower, 1.99 rupees per kilowatt hour, $27 per megawatt hour. For someone that's been in the the solar industry for 14 years almost, you know, that those kind of bid prices were, you know, really perceived as being really unobtainable even maybe 5 years ago. So it's really is a privilege to be active in addressing this market where we're seeing that pricing going in. So what we're seeing in Australia, it's in terms of big solar utility scale, and the market here in Australia uses between 80 to 90% single axis tracking for the utility segment, and a deployment rate for utility between 1 to 2 gigawatts per year. What we're seeing now is a lot of the low-hanging fruit is now gone. It's already built upon. And certainly the sites we're being asked to quote are becoming increasingly challenging in terms of either geotechnically, you know, they might be rockier or have reactive soil. Sites are becoming more constrained, so there's not as much, we're seeing not as much area. That's where module efficiency and being able to attain a good land utilization with your trackers is super important, especially for those plants that are co-locating with storage, where you're trying to get an effective cycling or utilization of a battery, which is typically the highest component of the system capex. Topography, we're also seeing many sites now, really developers and IPPs trying to address and deploy solar on sites with incredibly variable terrain. You know, really, you know, the historical perception of tracking only being possible on completely pancake flat sites is now no longer the case, especially with Trina's proprietary product features. We can deploy on sites with very high levels of variability. We're also seeing sites being requested now on sites that are prone to flood inundation. And also with the mining industry getting on board with renewables in a big country like Australia, some sites with incredibly remote locations, which bring with them accordingly a incredibly high cost to mobilize and demobilize that labor workforce, where there's not much readily available localized labor. But there's still a huge opportunity, right, despite those challenges. And this is why, for me, it's so exciting and such a privilege to be working partly within the Indian solar industry. If you see the chart on the left-hand side, well, actually, if I start on the top left, you know, the International Energy Agency, they see India as being the biggest driver of global energy demand in the next 2 decades. Where I think there's got to be a wall of capital unlocked in the order of about $500 billion to meet the energy growth demands and meet India's renewable targets. Truly staggering. What's possibly even more staggering is the chart on the bottom left, which comes from our friends at Rystad. You know, the capacity awarded in renewable auctions in India last year, pretty much dwarfing every other country combined many times over. I almost fell off my chair when I first saw this graph. And yeah, that's why for me, it's so great to be involved in the Indian industry. What we see in the bottom right here, though, is a chart where we performed a sensitivity analysis between Australia and Malaysia. So we recently quoted 0.5 gigawatt in the large-scale solar 4 round in Malaysia. And we ran the numbers for the cost of energy for single axis tracking at different pitches, or what we call GCR, ground coverage ratio. So if we consider first Malaysia, we saw actually, especially on Peninsular Malaysia, there's a really exorbitant cost of land because really, you know, there's not much spare land available. So accordingly, the lowest cost of energy is delivered at quite a compact 50% GCR, where the rows of the solar trackers are really quite closely spaced. It's completely the opposite story in Australia. A big country like Australia, there's no shortage of land, and at least away from the large urban centres where most of the utility solar is being deployed, the cost of land is actually really quite low. So accordingly, the lowest cost of energy is attained at a lower GCR, where the solar trackers are more widely spaced. You incur less near shading row to row, and the trackers can operate in outside of bat tracking road for much longer during the day. So accordingly, the energy harvest is much larger. Now, what I want to flag with this, and it's the same story in India, we think, based on the numbers we've run, especially in Rajasthan and Gujarat, where there's quite a low cost to acquire the land and no shortage of land, where we're seeing now at these lower GCRs, it actually increases your construction risk. You spread the rows more widely, you have to use more land for the same plant capacity, and accordingly your geotechnical risk, your topography risk, your risk of incurring flood inundation increases accordingly. So it's really, really important to partner with a tracker manufacturer who can mitigate all of these key construction risks for you effectively. So what Trina have done, we've got our integrated package of high wattage, low voltage bifacial modules from Trina, integrated into our smart TrinaTracker platform, which is unique in the industry. We're the only people offering it, this integrated package of module plus tracker. And we see that it unlocks considerable BOS cost savings and achieves the highest, and with really the most bankable entity in the industry standing behind the solution, Trina, the highest and the most assured long-term energy outcome for our customers. It's also important though, when moving, especially moving from fixed tilt conventional systems to single axis trackers, they've got drives and motors and things that move. It's important to partner with the tracker company who supports you, provides deep and close support at every stage of the project lifecycle. So we've got extensive engineering resources all through Asia Pacific. We can give our customers rapid site layout designs that are truly optimized for the lowest cost of energy. We can review your geotechnical and topography surveys to let that inform our layout design. During construction, we can parachute subject matter experts in at the start of your project to train your installers. Then we actually come along and lead the commissioning process ourselves at the end, and we stay on site for as long as it takes. And then during O&M and after sales, you know, there's a single point of accountability between both the module and the tracker. If there's any issues, you know, normally where the module's coming from one company and the tracker from another, the module manufacturer blames the tracker and vice versa if there's any problems. All of that technology risk goes away if you select an integrated module and tracker solution like Trina Pro. So this slide's pretty important. It follows on from what my colleague Lim presented to you earlier, just showing the module roadmap. Trina were the first mover last year into that large format module space, firstly to 500 watts. Then we moved on, our competitors caught up with us, then we moved to 550, then 600, and more latterly 660, 670. And that's important to flag that we were the first mover to that large format module space. But importantly and unique to Trina, we're the only module manufacturer to have acquired and repurposed a tracker solution specifically catering to these large format modules. So better than anyone, Trina understands the engineering challenges and complexities in integrating these large modules onto our trackers. And this is a really good slide. We can see with the 550 watt modules, you know, they're actually 20% longer. So what that means is when you put them on a tracker, and let's use a 2-portrait as an example, that cord length where 2 panels back to back are increasing by 20%. These are almost 5 meters long now. Really, when you're next to them, they're very, really quite imposing. The other engineering challenge is, especially with the Trina module with the low voltage, we can run up to 40 modules in a string in higher temperature regions. This tracker length north to south gets really, really long. And the longer the tracker distance north to south, the lower the natural frequency and the more propensity there is for the tracker to incur second order dynamic effects like resonance and galloping and fluttering at wind speeds lower than the peak wind speed that can be incurred on site. So there have been some of our competitors in the tracker space that have incurred some structural problems at less than maximum wind speed with 2-portrait trackers. Now, that's why Trina got on the front foot. We engaged the preeminent world-leading wind consultancies like RWDI and CPP to really, firstly, ensure absolutely unequivocally that there are no structural problems incorporating these large modules onto our trackers. And then we've had longer than our competitors because we've commenced the wind tunnel testing earlier. We've had longer to value engineer and optimize from a cost perspective for our customers, as we'll see in a moment. And one of the outcomes of the wind tunnel testing, especially for the 2-portrait, was we had to move to what we call multi-point driving. So we have a master drive in the middle with a linear actuator that's motorized. And then we utilize this rotating mechanical shaft with universal joints connecting to a slave drive at each end, north and south. And we find that really stiffens up the whole tracker structure and means that it's supported at both ends and really ameliorates this torsional stress that can build up in the torque tubes, And basically it means a tracker can't tear itself apart in this kind of twisting and torsional strain under these dynamic effects. So we've actually got two trackers. We've got firstly our Vanguard, which is a 2-in portrait. Both of our trackers have been specifically engineered to accommodate these large modules in these longer strings, including the 670 watt that my colleague Lim just mentioned to you. With the 2 portrait, there's individual row actuation, so there's no mechanical linkages east to west. We've got a proprietary bearing cap, a spherical bearing that can actually go up to 30% slope, which is really very, very steep when you see it in reality, and 15% is standard. And then because we've got 2 modules in portrait, we amortize the steelwork more effectively. So we only need 7 piles per table, or as low as, that equates to fewer than 120 piles per megawatt, or actually about 100 piles per megawatt with the 650s to 670 modules. So where you've got sites that have got challenging geotech or topography, we think this tracker is the way to go. It's the best to use on the more challenging sites. Then yesterday, we actually did the global launch of our Agile tracker. That's what we call a dual row, where one row, it's 1 in portrait in terms of configuration. And then one module, one row is mechanically driven and linked only to one neighboring row. So you still have completely unimpeded vehicle trafficability between every other row for O&M, vegetation management, cleaning, and so forth. But there's fewer motors, drives, tracker controllers, batteries per megawatt, in the order of 30 to 40% fewer. And so that's cheaper for us to supply our customers. And there's fewer critical components that require maintenance, corrective maintenance during O&M and after sales. So this tracker is actually a bit cheaper to supply. And for that reason, we say this tracker is the way to go for less challenging sites. We look at the cost savings, though, from a CapEx perspective, when we put a Trina 540 compared to a competitor 540, and we see the low voltage here and the low pile count, unlocking construction and CapEx savings we see on the waterfall chart here in excess of 1.5 US cents per watt peak, which is very significant. We also have our intelligent SuperTrack tracker controller, which can unlock 3 to 8% more kilowatt hours per kilowatt peak for our customers, especially in heavy cloud cover events and sites with uneven terrain. And just moving towards the end of the presentation here, we've run the numbers many times in India. This is an example from Rajasthan, where we're seeing the 2 portrait tracker unlocking the lowest cost of energy, less than $30 US per megawatt hour, 25% more kilowatt hours per kilowatt peak than fixed tilt at the top here. And needing more land in the order of 1,000 acres instead of closer to 500. We've plugged the cost of land into this simulation, so it's conservative. Tracking does require more land, but even with that penalty and things like we've assumed 10% duty on the import of steel for the trackers, 0% for fixed tilt from India, and 20% higher O&M OPEX. We're still unlocking between 5 to 7% lower LCOE as compared to fixed tilt. We'll just finish on some reference projects here. We've deployed our technology in some of the largest tracker projects on the planet. This is 602 megawatts for the Huanghe project for State Power Investment Corp in China, one of the largest tracker projects on the planet. The Grasshopper project, 103 megawatts in the US, and the 2 portrait, you can see the slope tolerance here easily traversing these changes in slope on the site. And in Australia, we've done 120 megawatts actually in cyclonic Northern Australia in Queensland back in 2018 without any incident whatsoever. So Trina, really, we innately understand how to make tracking work in high wind regions. And then that concludes my presentation. Thank you very much.
Thank you so very much, Mr. Lim and Mr. Andrew, for this wonderful presentations and setting the tone for today's event. Now, ladies and gentlemen, let us move forward with the panel discussion. Rather, I would say it's an OEM developers interaction where we can have a more in-depth understanding of the product and services from different perspectives. So in today's esteemed panel, we have Mr. Bimal Jindal, Director, Supply Chain Management, SB Energy, Mr. Gautam Samanta, Head PV Technology, Juniper Green Energy, and he is also our session moderator. Mr. Lim Changboon, Head of Product and Marketing, APAC, Trina Solar Asia Pacific, Mr. Andrew Giholi, Head of Trina Pro APAC region, Mr. Srinivas Popuri, Vice President, Group Quality, Greenco Group, Mr. Vinay Vyas, Vice President, IBT Engineering, Acme Clean Tech Solutions Private Limited. So let me hand over the session to our session moderator, Mr. Gautam Samanta. Mr. Samanta, the screen is all yours.
Hello.
Good afternoon. Yes, Mr. Samanta, can we have you?
Yes, I've already opened my things, Okay. Can you win the screen, please?
Yes, we can hear you. Yes,
yeah.
Please.
Okay. Good morning, everybody. And this is Gautam Samanta from Juniper Green Energy. Today's webinar, we will talk about the ultra-high efficiency, ultra-high, higher wattage modules, there was a good presentations from the Lim as well as Andrew. So first of all, we will see that how these big modules will be, suitable for the future market. If you look into the history, like we have more than 600 gigawatt level of installation globally, and in India it's close to 40 gigawatt, almost 6.5% of the global market share. But all our past experience, I think is a moderate power, in essence, like 410 to 450 watt up to maximum, and now we are going forward with the 550, 600, and 670. So if you look into the photovoltaic industry, like the larger size of the modules means we have to look into the inside of the how much the cell size is it, whether it is a M6 or M10 or M12 type of wafers. So earlier there was a small wafer and it was a full cell, and if you look into the poly modules, the poly modules was size was okay. I mean almost 1 meter by 2 meters, 2 square meters. So now we are going with the larger modules which are almost 3.5 close to 2.8 square meter to 3 square meters, So and where cell size is much bigger, but obviously now the cell size is half cart or maybe 1/3 cart, So we will try to understand, from the good panel discussions and from the experts, how it going to benefit it for the futures developers as well as the way forward, and what are the different features that we'll add to. First of all, I will ask Vinay. Vinay, you're on the screen.
Yeah. Hello, everyone. Good morning. I'm Vinay from Acme Clean Tech. Thanks Solar Quarter for organizing this webinar. And thanks to Trina Solar for coming up with new technology, high watt peak modules, high efficiency modules. And that's the need of the hour as we're looking at more competitive prices. The overall economics needs to be improved. The LCOE need to be improved. So it's a good move.
So first of all, I think I will ask Vinay, as we are going forward with the high power modules, from the project point of view, I mean, you have another 2.5 gigawatt level of project on pipeline, So looking forward from the engineering, because you handle both the engineering as well as international business development, So from the engineering point of view, how this the high power or ultra high power modules, both the monofacial as well as in the bifacial, is going to be benefited, and how to plan it, if you can share some of your thoughts,
Sure. So like last many years, what we are seeing that we were using M2 wafers, and year on year, the efficiency of wafers and modules were increasing, but the size of module, size of wafer was stagnant. But in recent few years, industry is moving from M2 to M6 to M8, and now we have M10 and M12 wafers. Trina is coming up with M12 wafer, which is 210 mm and higher power, higher size of module. And in terms of planning, right from transportation to installation to commissioning, thorough analysis is required because the size of panel is larger. In terms of BOS saving, which we were discussing, the good advantage with this module is that it has lower voltage rating. Because of the lower voltage rating, we have higher power per strings, and there will be a significant reduce in the string number of combiner boxes, connectors, the land requirement, and civil cost. But at the same time, the challenge which we are seeing in engineering is that it has higher current compared to the traditional modules. And the current is almost double what we're seeing from the traditional module, which we are seeing is around 9 to 10 amperes. The current is around 18 amperes. So in terms of design engineering, we need to be very thorough in terms of sizing of cables, the losses which we're going to meet in the project, the sizing of protection and the fuses, the combiner boxes, which is there. We need to be very thorough on sizes of these combiner boxes. Because of the high current, there will be more heat dissipation inside the combiner boxes. So we need to be very thorough in designing such combiner boxes and system protection. Structure part also, because the size is bigger, but thorough analysis is required in structure designing and proper stat models to optimize the design to accommodate this higher size of modules. And at the same time, we need to be adaptive for such changes. But what we request from most of the module manufacturers, that we need to be very thorough in the changes we are making. Because if we keep making frequent changes, then industry will not be adaptive to take these changes. Proper time need to be given to all the segments of solar industry, including EPC player, developers, BOS component manufacturer, to adopt these changes, because there's a drastic change in design engineering of these components. And by giving thorough analysis of such these changes, we can get maximum advantage out of this technology. Bifacial module is also getting popular day by day in India, considering its higher generation, and it can be used in both fixed tilt and tracker. But as rightly presented by Andrew, that we can get a significant higher generation and better LCOE with bifacial and trackers. And this is also we are examining in many of our projects in Rajasthan and Gujarat. Overall, I would like to say that this higher efficiency, higher power modules is need in the industry. But at the same time, we need to give more time to the industry to adopt these changes, because there is change in the entire BOS component design and engineering. Thank you very much for the invite.
Okay, thank you, Vinay. It is a fantastic. I think you have rightly pointed out, because the higher wattage modules, if you see that the current is more and the voltage is low. So if you put your string design as the low voltage, you can accommodate more number of modules, almost 20 kilowatt, So you can save a lot of on your BOS cost cable structures and all. But to handle the high current, you have to be very careful about the cable, the current rating and all, what type of cables. Sorry, I think you have rightly pointed out, it can accommodate, more power, almost 20 kilowatt per string levels. And but because of the higher current, you have to be very careful in your system designs. Thank you very much. Next, I'll go to the leap. Already you have introduced yourselves through your presentations. As we have seen that last few years back, The poly modules where it was almost like a 320, 330 watt. And after 25 years, the power output was almost 80.2% or 80.5%. But today, if you look into the module that we are getting mostly in the mono, and after 25 years, the power what we are for the monofacials is almost 85%, and for bifacial is 87%. From the product point of view, how you are ensuring that such a low degradations, and it is a beneficial for the developers in terms of the power generations. Lim, if you can share your thoughts. You have already presented very nice presentations.
Thank you, sir. Yeah, I think this power warranty or power guarantee derogation is a important factor in all the power plant design. So you can see last time Mr. poly cell, and then now we are using the mono cell together with the PERC technology. Yeah, at the same time, I think a lot of the wafer now are also gallium doped wafer. So all these factors will contribute to lower the annual derogation of the module. So this is something that from the previous experience, if you look at, I think the solar module has been in installation for more than 20, 30 years. So if we do some comparison with the previous data, you'll see that actually these numbers are still borderline on the more conservative side. So in actual situation, for a proper operating module, it should derogate even less than what is guaranteed by the different manufacturers. Yeah.
Okay, thank you, guys. I think both the product point of view as well as performance point of view, you are 100% sure that the product will be, warranty for 12 years. And I think you have got more than 60% of your product under your control. I mean, maybe the manufacturers of Trina, And the next is in terms of the performance for the low degradation. So you have a different kind of third-party laboratory. In spite of your own laboratory test, you do do the tested by the third-party laboratory, and we are ensuring that the lower degradations of your product. Thank you very much. And then next, I'll go to the Andrews. Andrews, you have a nice presentations in terms of the trackers. As we go forward, we had seen the industry is mostly adapted on the fixed tilt structures. Now with the fixed tilt to going forward to the the tracker is a new technology. So how did you see that tracker is a good market not only for India as well as globally, and how you can see that this will be a much better generations, and also it can achieve the LCOE.
Sure. Yeah. Thanks, Gautam. So I'll bring it back to that earlier slide in my presentation. We're seeing these precipitous declines in LCOE in every market, and one of the I guess one of the more recent markets to where we've seen a spike. There wasn't too much engagement there until we saw this super low pricing going in India. Then we saw a very rapid shift in India in interest to re-engage with exploring the possibility of tracking solutions and how they can get to this lower bid pricing. I think so it all has to come back to the energy, and with tracking, we see now yield. It unlocks that lower cost of energy predominantly through the higher energy yield, right? So we see typically 20%, sometimes as high as 25%, depending on the location, more kilowatt hours per kilowatt peak. That's a huge number. Previously, I think the challenge for trackers in India was as the price of modules kept on getting lower and lower, in relative terms, the cost of the trackers in the capex got higher and higher. It couldn't justify the extra capex spend wasn't justified with the trackers. Now what's happened is the cost of the modules has actually gone up a little bit, whereas the trackers have continued to decline. So that premium has gone on CapEx has gone from about 14–15% to 10% or less in India for 20 to 25% more energy. There's different value stacks in different parts of India, like in trackers are all about capturing, you know, even if you've only got an accuracy of plus or minus 5% of keeping the panels close to the sun. With tracking, you still capture 99.6% of the direct component of the irradiance and really, really minimal reflectance losses. Now, somewhere like Gujarat or Rajasthan, you've got a super high direct components of irradiance. And the other benefit with those regions, which are a bit more arid and dry, you've also typically got a really good albedo. So using bifacial, you get really good reflectance off the ground and hitting that irradiance hitting the back of the module. If you consider somewhere a bit more equatorial or further south or tropical like Andhra Pradesh, you know, the challenge or the customer objection about tracking previously was, well, if you're closer to the equator, tracking doesn't stack up financially. The synergy of using bifacial on trackers is you get a boost from bifacial in heavy cloud cover events, right? So where you go a bit more closer to the equator and you get really pronounced monsoon seasons and a lot of the year in heavy cloud cover, you actually get a relatively higher boost from the bifacial panel. So that can restore the tracker advantage from 15% back up to that 20% even in Andhra Pradesh. So that's where we're seeing, you know, we're seeing Gujarat and Rajasthan between 3 to 7% lower LCOE. That's where the land is a bit cheaper, and that's where you know it pays to go a bit wider with your tracker. In Andhra Pradesh, where you know the land is a bit more harder to come by and a bit more expensive, we see that LCOE reduction in the order of 2 to 5%. How do we get to the lower capex? So it's things, as I said, like you know, fewer foundations per megawatt, as low as 100 piles per megawatt now, whereas, you know, that can be in excess of 400 with a fixed tilt per megawatt. So where you're pre-drilling and filling with concrete, even in India, 400 piles with concrete is going to be quite expensive, right? So where you've got something with a quarter of the foundations, that can really recoup and save some of your construction cost. Also, the slope tolerance, you know, you'll see, I think you'll start seeing in India what we've seen in Australia, sites considering utility scale solar that are not completely flat anymore, but deploying on the sides of hills and you know, the challenges that brings with it. So we're seeing you know, tracking now reaching that potentially equivalent capex, installation capex compared to fixed tilt for a much higher yield, and that's I think that's really, you know, competitive capex with a much higher energy yield is how we're getting there. And then when you integrate a low voltage panel where you're getting these super long strings on a tracker that's been specifically engineered to accommodate these longer strings, that's where we see this value stacking really where we can deliver the most value to our customers.
Thank you, Andrew. It's fantastic. I think you have explained very nicely. Obviously, it will be location specific, that everywhere we cannot put our trackers, you know, right? In the different locations, we have a different kind of generations. We have to see that obviously in the structure design as well, in how you get your albedo and the tracker design, not structure, is a tracker design, right? Thank you. And next I'll go to Srinivas Papuri. I think he's a quality head in Greenco. Can you introduce yourself and then I'll ask the questions. Srinivas ji.
Yeah. Good morning, everyone. I'm Srinivas. I'm heading the quality in Greenco, all the vertical solar, hydro, and wind. And I have a pleasure of working with Trina's team in one of our projects, and I have visited their plants. And really, I think I would like to say that technically, I'm personally very impressed with Trina's team because. We have seen that while discussions, they discuss in depth, but once they agree on certain points and factors, they stick to it, whatever comes. So I really appreciate the Trina's team and their efforts. And I think this is one of the reasons why they're coming with new technologies to give us as developers a lot of scope and advantage going forward in the current LCOE thing. So,
okay. Srinivas, I think we have a time, I think another 5 minutes more. So first of all, I'll ask you, as you have got such a huge experience with the Trina, but those experience with the poly like 330, 325, what modules, as we are going higher, what is modules? Not only that, the cell that are using is nowadays are 182 millimeter, or Trina is in 210 millimeters. From the developer's perspective, so we have to ensure, first of all, in terms of the quality, I know there is a legal contract that you sign and you obey that quality. And secondly is the reliability. That means how it is reliable, that the low amount of degradations which are ensuring, on a year-on-year basis, so we have a better generation, and whatever your, Excel sheet, that the kind of the tariff that you are getting. So you are ensuring from the quality perspective, yes, I am getting that product, and that won't be any kind of problem for future. Can you explain a little bit on that?
Yeah, definitely. See, one good thing is, as I told you, the new modules are coming, but that again puts a lot of pressure on the developer in terms of engineering, as Vinay was explaining, and also quality, because the standards, IEC standards, we say they are not very concrete. They are still little fragile. And in this changing technology, how to go about the testing is one very big question. What I have on my mind and my team is to cope up with these kind of changing scenarios. And now, if we talk about monoPERC, okay, I've been asking to many suppliers that what about the effect of LETID? That is one of the major factors which will determine my reliability of the module. So how the manufacturers are going to safeguard my modules from this phenomena. So I have not got a concrete answer till now. They have been answering somehow, but I think this is one question I really want to have a convincing answer. This will definitely bring a lot of reliability in the modules once I come to know about those things. The other aspect of testing during manufacturing would be mechanical load testing. Okay, this is in relation with the bigger size modules. The mechanical stresses may be more. So how they are going to counter these things is the other one which the developers want to know. And like rightly you rightly said, the bigger size modules, the bigger size cells, there is a high probability of microcracks during installation, especially in the Indian context, where the contract workers are not very trained and regarding the sensitivities of the module handling. So whether manufacturer is having some safeguards for preventing these kind of microcracks developing during handling of while installing the modules is one thing which definitely would give a lot of confidence to the developers like us. And also the 1/3 cut cell, like 3-way cutting of the cell. So how reliable it is would because in 2-way cells, I think they're definitely, whatever they say, there are some mechanical stresses which are formed. So I think Liam has explained how this low temperature cutting is going to take place, but I think we should learn more about that. So, and also due to the bigger size modules, though I'm saving on a lot of things, BOS, but what happens is generally I say, okay, manufacturers tend to take a lot of time determining the cause of failure. In this scenario, if it is a smaller module of what we have, 340, 345, 350 module, I may be losing very small amount of power. But if it's a bigger size module, the downtime may be more and outages could really be high. So these are some of the questions what we as a developer we have, which require some answers from the manufacturer.
Thank you. I think you have rightly pointed out, this bigger size module handling, we have to see, first of all, during the installation stage, how we can very correctly handle without any kind of creating a micro crack. So after that, I don't think there is any issue. But as you know, there is load as far as nothing, no concern. But there is a dynamic load in case of there is a high wind speed zone that is unpredictable. So that's not in your hand. But handling has to be, we have to think about how can it be a little bit automated, in a sense like in the vacuum cup, pick up and put it onto the on a table or in a rail or something, a sliding or something like that, so that it doesn't get any kind of a micro crack, when the levers in the site, they are two persons are handling like that, Okay, next is Mr. Bimaljin. Can you introduce yourself? I think we have very less time now. Bimal.
Yeah. Good afternoon, everyone. My name is Bimal Jindal. I head supply chain for SV Energy, which is part of SoftBank Group. Yeah.
Okay, Bimal, I think now if you see the last bidding which happened in India, 2 rupees 20 paise, and there is a cost like BCD is already involved. And also without BCD also rupees 2. So if you see here, then as a developers, we can see that there is no other options other than we have to go for it. We cannot go for a fixed. I think we have to look for a tracker with a bifacial module. So what is your opinion on that, so that we can take it for the future installations? Like we have done a lot of project in a pilot plant, but for a mass scale, installations, how we are ensuring that, we can match our LCOE, which is the numbers because of the better generations, as you see for the bigger size modules,
No, I think first of all, I want to appreciate, Lim and you. I think they beautifully explained about the larger size module and tracker. And I heard, Vinay and Srinivas talking about some of the constraints. So I believe the simple answer is yes. So if we want to go for a better LCOE, I believe bifacial with tracker is going to the future. Now, it will take some time. I think there are a couple of factors. Let's look into the modules. Previously, if you look, the market was focused mainly on poly because of the price gap between mono. They were not ready. Now, with mono being competitive and the bifacial and mono is coming under less than 1 cent, so that is giving a very, very big competitive edge. Previously, people are not able to use the bifacial because the deltas were pretty high. The second part, the tracker, if you look at in India, were not be able to, fully, I will say, use its potential. I personally did a couple of 100 megawatts of project with trackers, but that time the module price used to be 50-60 cents. And if you look at the tracker cost, which used to be 14.50 cents in 2013-14, still, has not come to the single digit. Although I saw, Lim and Andrew showing the slides, which was like 10% going to, 8.8 or 9 cents. But the reduction of module price versus tracker price is not proportionate. If it could have been proportional, the tracker could have been in underutilization the same way. So with the technology advancement, I think the monofacial module are not going to be used. The bifacial and mono delta is pretty less. The second part, the efficiency of panels has increased. I was looking, it was 21.6 for 670 watt peak panel. If the efficiency is same, only the size is increasing, then also it's not helpful. So that definitely going to give a lot of edge, because the tracker costs are directly proportionate to the efficiency. The bigger size, I will not go with the notion of size. I think we need to look into the efficiency. I was looking into what Lim showed, the 550 to 600, they just increase the size. The efficiency was not changed, but I believe when they went from 600 to 670, they changed the efficiency. So that is going to help. There are some industry concern, which Vinay has rightly pointed out. The BOS system compatibility, I believe the backward supply chain need to be ready. Second, handling of modules. If you look at this module are like 38 kgs. The typical module which people are used to handle was like 20 to 22 kgs. So we need to see how people are going to handle that on site. So there might be some execution challenges, which will not be easy, but in overall, the efficiency is improving. The tracker cost is going to decrease because of the betterment of efficiency. Plus, even the logistic costs are going to decrease based on the way they are going to rack, stack, and again, the way they're going to plan. I think this definitely going to help uh, a country like India. If you look into the northern part, we have a lot of potential, and we will be able to harness the full bifacial part with the use of tracker. If it is fixed tilt, it will not be possible. So this is going to be really good in terms of lowering the LCOE. I believe the people who are quoting 2.2 rupees, definitely considering all these factors. They will not be able to do it with the plain vanilla, poly or mono fixed tilt projects.
True. Appreciate. I think you're rightly pointed out. Okay, I'll take it. A couple of questions. I think you have the answers. The last year in SNEC in 2020, Trina launched the product at 670 watt, and a couple of other suppliers so 780 watt, 800 watt. So if you look, Trina has already 670 watt, which has been launched. So why not in China? It has been. I know China is already one of the biggest market. How did you feel that it has not, installed in China? What is your comments on that?
Yeah, hi sir. I think no. Having been in the industry, I think all the panelists here are long-time veterans in the industry. So if you look at how the panels have been developing, overall it takes a bit of time for the acceptance whenever some new technology or the new sizes that is coming into the market. So as an example, you see last time the system voltage is only 1000 volts. And from the 1000 volt, when we shifted to the 1500 volts, there was a lot of question on, can the module handle this? Can the inverter handle this? Can the cables, connectors, all this was thrown out in the question. So, but eventually,
next is that,
overcome this, and now it becomes the new standard that everyone is adopting. So
I believe that with the time, I think China is also will be adapting, 660, 670 watt. Yeah?
Yes, sir.
And then that will be experience for us. India, we adapt, tomorrow, not today. Like the new product, we are always a little bit skeptical, and we take the best practices and pros and cons like that. Coming back to the another questions, particularly for the bifacial modules in the PV simulations, what is your idea that we get the right numbers in the generations from the monofacial front side as well as the bifacial from the rear side generations with the temperature coefficient and all taken into the considerations?
I think now with the experience accumulated, we've get a more and more bifacial installation. So after at the PVC level itself, with some of the tweaking, actually we can get a fairly accurate simulation when even for the bifacial module.
Okay, thank you very much. I think time is already up. So I'll ask Solar Quarter follow up to take it forward. Thank you very much, panelists, for your valuable discussions and the suggestions in today's webinar.
Thank you so much, sir. Now, with this, ladies and gentlemen, we come to an end of our very interesting webinar. I would like to thank all our dear panelists for sharing their valuable insights. A special thanks to Mr. Gautam for an amazing moderation. On behalf of First View Group, we would once again like to thank Trina Solar for giving us this opportunity. And a big thanks to all our lovely audience. Forward to meeting you all at our upcoming conferences too. Till then, stay safe and stay happy.